All right, I'm going to try this again. And I connected to the internet. So see how this. I tried this many times. I lose mine. I definitely see me. But what this is all about is functions. There's a lot of things that I tell you guys that you ask, will I ever use this? I'm like, I don't know, depending on what field of study you go. This is one of those things that I can say you will use. There's going to, I can't even concentrate because my children and the dog, I'm so sorry. They're back here fighting. My son and the dog that's now bigger than him. Anyway, this is one of those things where if you ever have money in a bank account, which I'm sure at some life all of you will, that this is going to apply to you. Or if you ever borrow money, and I'm sure once again at some point in your life, all of you are going to do that. So with whatever the case may be, this lesson is applicable to that. So get started. The vocabulary of today is writing an equation or an exponential function, writing an exponential function. So what is an exponential? An exponential function. We're going to talk about the exponential function. It's in the form y equals a times b raised to x power. So we're going to look a little bit more if this ever pops up here. We're going to try to look at writing an equation, get 2 points. I've done this so many times that I've got it memorized, so but it looks, I believe, we tried on. But we're looking at the points 1, 6, and I think the other one was 3, 4. Okay, so we're looking to write an equation that passes through these 2 points. So what I'm going to do is I'm going to take them and plug in into an equation and for a variable. So y is 6. I don't know what it is, but I know y is 6 when x is 1. So that's how we get like so a is nothing more than 6 over b. Okay, so getting closer worked out here. Let me make my screen of me just a little bit bigger. Okay, and over here I know when y is 24, x is 3. So I would have a times b to the third. A is 6, so we're going to plug that in here. So 6 times b to the third. An easier way to write that would be 6 times b to the third is equal to 24. And that quickly the third, really I have b times b squared. Okay. Those canceled. So 24 equals 6 times b squared. I'll get b all by itself. Divide those by 6. And 4 is b squared. I don't want b squared, I want b. So if I take the square root of the size, I get b is equal to 2. Now that I know that b equals 2, what I can do is take that and plug that in the equations. So I have when y was 6, a we don't know. We know that b is 2, and when y was 6, x was 1. So now we can use that information to solve for a. All right, so 2 is nothing. I divide both sides by 2, and a is equal to 3. The equation is y equals a, which is 3, times 2 x power. And now this equation will satisfy both points, and we can use it to find other points on our graph as well. I don't know why this looks so funky. So you don't have it in my, so hopefully let's pray here. So if you're following your work, you see there, and what you're going to do is click on each of the points you can get on McGraw-Hill. You can look in your workbook. Points, there's a point at -2 and I believe +10. Hopefully this soon and very soon. Go ahead and make me smaller. Come on. Come on. All right, there we go. So I'll plug them in. -2, 10, -1, 5, 0, 2.5, and 1, 1.25. So we already know that our y-intercept is at 2. So that's automatically mine. And you can test that out, but I'm not going to take the time for the video to do that by plugging up and solving. But we know that A is 2.5. We don't know what B is, but we know that when X is 1, Y is 1.25. So I'm going to plug that in, and now I have enough information that I can solve for B. So what I'm going to divide both sides by 2.5. 1.25 divided by 2.5, I can tell that's half, so that's 0.5 or 1/2. That's B. So now I have an equation. Y equals 2.5 times 0.5 raised to the x power. Now, I want you to look at this equation. We talked about yesterday how if this value of B, the value that's raised to the power, is in between 0 and 1, then it is showing decay. If it's 1 or higher, it is showing growth. Remember, decay means going down as the graph moves left to right, and growth would be going up. So this would be a function whose value for B is greater than 1, and thinking that you can see and you can't. And then this one, B is between 0 and 1. This is what it looks like. If you look at it shows value is between 0 and 1. So this is letting me know that's an correct. So example 3 here. It says write an exponential function given a description. So this time it tells us the radio station is giving away $1,000 to the first listener who answers a question correctly. If the question goes unanswered for 1 hour, the prize increases by 10% until it is answered correctly. So write a function to describe the station. So we know right off the annual amount is $1,000. Where we're starting. X is 0, Y is $1,000. So that's our initial amount. That's the A value is $1,000. Okay, we also know that they're increasing it at 10% as time passes. So it's tempting to just put 10% same as 0.10. It's tempting to just put 0.10 raised to x. But on that previous slide, we just mentioned that if this value of B in between 0 and 1 shows decay, this is saying that they're adding 10%. The prize is increasing by 10%. But we're keeping all of this value, so 100% of that, and an additional 10% each hour. And so that's where these numbers are coming from. It's kind of dark. You can kind of see better, actually. 1,000 is our initial value. You're getting 100% of $1,000 and an additional 10% raised to the number of hours that pass, and that gives Y. Except if you want us to use y, and x in this problem. They want to use, let's see, I can't remember what it is. I think P for pride and H for hour. Yeah, it's right there on the table. So P is equal to 1,000 times 1.0 the number of hours. Our A is our y-intercept. That is 1,000. Is this the best models? Is that the dog? Or are you screaming? Oh, I'm sorry. Trying to be dog, trying to teach. What my crazy wife. So, anyway, equation works. Looks to me like D is the correct answer. P is equal to 1,000 times 1.1 H. That is correct. Alright, I'm going to stop this video here today. I'm seeing that my children and my dog are out of control, and I'm going to convene here in just a few seconds with a video for the next